Welcome learner to our today's lesson, our maths lesson. And our today's lesson will be a new topic, a topic known as measurements. And in measurements, we're going to discuss about volume, we're going to do capacity, and then mass. So in this chapter, we're going to look into three areas: volume, capacity, and mass. But before then, there is something I forgot to mention in our previous lesson about a surface area of a pipe. Just seen a question somewhere, and they are talking about a pipe. This question goes like this. A pipe has a radius of 14 millimeters. A pipe has a radius of 14 millimeters. The length of the pipe is 50. The length of the pipe is 50 centimeters. What is the area of the pipe? What is the area of the pipe? Take pi to be 22/7. Now, learner, whenever you're given a question like this, it is very, very important that you draw the question, you draw the diagram. So we are going to have the diagram, and the pipe is supposed to look like this. Just draw it like this. We are told that it has a radius of 14 millimeters, and the length is 50 centimeters. If we change this, it's going to be 500 millimeter. Now, one thing I want to talk about in a pipe is that if you have a pipe doesn't have the two circles, so it's a through one. So if you are considering that, then when you are given to look for area of a pipe, you just look for the curved surface area. So we are going only to look at the curved surface area, because the first part, which is for the two circles, 2 pi r squared, is not there, because this is a hole, the other one is a hole. It's a through thing. So it doesn't have these holes. And remember, we are calculating, if it's surface, with the two circles, we are calculating the surface which is there, but there is no surface here. It's just a throwaway. And so whenever you are given a pipe, you need to consider that. Just calculate the curved surface area. So the formula of getting curved surface area is pi dh. Remember, we wrote something like this: 2 pi r squared plus pi dh. This is the formula for a closed cylinder. But this is not there. There are no, if it was leads, there are no leads there. So it is this which remains. So we are going to take pi 22/7 times the radius 14, and then the length. Now remember that a pipe doesn't have height. What is there is a length. So this length, which is equivalent to the height of that, is going to be 500 mm. So this is going to be 244 times 5. 44 times 5 is 220 plus 1 2 millimeters squared, or if you want to write in centimeters, of course you change this into centimeters and get your answer. So that's what I wanted to mention about a pipe. So in a pipe, we don't use the 2 pi r squared. We use pi dh. Whenever you are given a question about pipe, use pi dh, because we are only looking at curved surface area. Now, back to our lesson of today, that we are going to look into our volume. First, we are going to calculate volume. And before we just do volume, we are going to do cross-sectional area of cuboids and cubes. Cross-sectional area of cubes and cuboids. Because from the knowledge that we'll get here, that will be able to go and calculate volume. So we are going to do a cross-sectional area. Now, if you remember what a cube looks like, a cube has all the sides equal, so it will look like this. So that is a cube. If this is 3 centimeter, this is also 3 centimeters. So if you are told calculate the cross-sectional area, in this case, this will be the base area, because this is at the base. So we are going to look for the base area. Base area. And base area, you just multiply, because this is the same, you just take 3 centimeter times 3 centimeter, and that will give you 9 centimeters squared. That will be the cross-sectional area, which is the base area. If you are given something like this, a cuboid, then you ask find the cross-sectional area. This is colored, for example, this is 15 centimeter and by 3 centimeter. For us to be able to get the cross-sectional area, this cross-sectional area, is going to be, there is going to be 15 centimeters times 3 centimeters. That is going to give you 45 centimeters squared. So the cross-sectional area is going to be 45 centimeters squared. So that's simply how we get cross-section area and the base area of a cuboid and cube. Now, after that, we'll be able to do volume. I said, after knowing that knowledge, after getting that knowledge, we go to volume. Volume of cubes and cuboids. There's not much to discuss here. Something that is very cheap for us to be able to understand. So I'm going to draw a cuboid here, and a cuboid we know has rectangular faces, and so told this, we are told this surface here, the down one, which is the base area, measuring 6 centimeters by 4, so 4 meters, 6 meters by 4 meters, and a height of 5 meters. And our question is, a rectangular room measures 6 long by 4 wide and 5 high. If the room is stacked with boxes of 1 meter cubed, how many such boxes will cover the floor to make the first layer? If they are going to be of 1 meter high, so you can calculate that it will be 6 times 4 times 1. 6 times 4 times 1. If you only want to cover a height of 1 meter, because they're supposed to be 1 meter high. So what we consider in that case, we don't consider the length. Sorry, this is supposed to be 4. Then this 6. All these are meters. We don't consider the length or the width. What we look at is the height. So in this case, for us to be able to pile for one layer that is 1 meter high, that is going to be volume, that is meter cubed. It's going to be volume is separated by length times width times height, or simply base area times height. Simple as that. That's why we did base area and cross-sectional area. So in this case, our volume is going to be 6 meters by 4 meters. That will not change. And what will change always is the height. So we are told that they're supposed to pile each to 1 meter high. So we are going to multiply that by 1. That is going to give you 24 meters cubed. Meters cubed is put a small 3 above the meter. So that is 24 meters cubed. Now, assuming they want to cover the whole rectangular floor, what are they going to use? So if they want to cover the whole rectangular floor, they are going to take length times width times height, but our volume now will be equal to the cross-sectional area, which is 6 meters times 4, that base area times the whole of it. They want to cover the whole room, so they will cover 5 meters. This is going to give you 30, which is 120 meters cubed. So the volume of this room is going to be 120 meters cubed. That is just one example I have given. I want to give several other examples so that we understand exactly what we are doing. Question goes by, I want to carry out a simple question here. The area of bottom of a rectangular container, the area of the bottom of a container, that is a rectangular one, sorry, I failed to write that. Rectangular container is 180 meters squared. If the height is 25 centimeter, if the height is 25 centimeter, what is the volume of the container? What is the volume of the container in centimeters cubed? In centimeters cubed. We need to understand first what volume is. And volume is the amount of substance. The amount of substance, amount of matter in a substance. For example, when you put some 1 liter of soda in a fridge, that 1 liter is equivalent to 1,000 cubic centimeters. 1 liter is 1,000 cubic centimeters. But that liter, the 1 liter, in that case represents capacity. But if you want to change that capacity to volume, then that 1 liter is 1,000 centimeters cubed, which is just 1 meter cubed. So what we do here, you need to draw the area of the bottom of a container. So if it's at the bottom of the container, then that is base area. So we draw like this. It's a rectangular one. So the bottom here, this bottom, its area is equivalent to 180 meters squared. Then you are told this height is 25 meters. The question is, so these are centimeters. These are centimeters. The question is, what is the volume of the container in cubic centimeters? Volume, you write the formula, is calculated by base area, which is BA times height. This is base area. But if it's on sides, we call it cross-sectional area. But once it lies at the bottom here, because it is called base area. That's why you saw what I was doing here. So the volume will be equal to the base area. Our base area is 180 centimeters squared times the height is 25 centimeters. Now I want to show you what base area is. You only get base area when you multiply the length and the width. Those two, when you are looking for volume. When you multiply the length and the width, you get base area. But when you include the height, now you get volume. That's why this is already length and width. That's why we are not saying length and width again. We call it base area. Because base area is length times width. So when it has already been multiplied, we don't call it length and width again. We call it base area. What is lying there on the surface is the base. So area of that base times height. So that's where we get base area from. So this is going to be, so I don't want to see you again writing volume is equal to length times width times height. That formula is wrong in this case. In this case, when you're given the base area, you write base area times height. You don't write L times width, because L times width is what is given here. But if you are given, for example, a question like this 4, 3, 2. They have not given you base area. So what do? You write the volume is equal to length times width times height, because all of them are here. So that's why I wanted to explain. So you get 180 times 25. 180 times 25, that is 18 times 25, then you add the 0. 9, 6, 3, 0, 5, 4, 0. So 4,500 cubic centimeters, centimeters cubed. So that will be the volume of that particular rectangular shape. The last one, before I give you some work to do. Let's do another one, so that I give you some question. I'm going to draw here that we have this. So this is 20 centimeter by 30 centimeter by 25 centimeters. Find the volume. So volume is going to be the length times width times height. Remember here we are not given the base area, so we cannot use the formula base area times height, because the length and the width are already here and they are not multiplied. So our volume is going to be the length, which is 30 centimeter, times the width, which is 20 centimeter, and then the height, which is 25 centimeter. There's a way you can be able to multiply very fast. You ignore this 0 first. You have 1, 2 zeros, then 25 times 2 is 50. 50 times 3 is 150. So you say volume is equals to 150, then you want 1, 2 zeros, like that. This is going to be centimeters cubed. So now that's how you can be able to multiply and get our volume. So for us to be able to practice and get that question and that chapter well, we go to exercise 83. Exercise 83. Primary mass exercise 83, 84, 83, 84. Now, there's something small that we need to do so that we do exercise 85. We do those 3 exercises. Now, let me explain exercise 85 because it concerns what we have just done. You are given a table there. We draw an example of that table, so that we'll be able to understand the length, the width, the height, base area, and volume. So the box says your total box A is length. I just put L. Then the width, height, base area, and then the volume. I write volume like that. So if you are given, for example, you have been told box A has a length of 7 centimeter, a width of 4 centimeter. The height is not given, but the base area is 28 centimeters squared, and the volume is 84 cubic centimeters. Find the height. Find the height. So you need to understand what we are given. In this case, we are given base area. So you say volume is equals to base area times height. Very well. Now from there, you replace what you have. Do you have volume? Yes. So you say 84 is equals to the base area. Base area given? Yes. Base area, which is 28 centimeters squared, times, is height given? No. Times height. So 84 is going to be base area, which is, now, in this case, we are going to multiply here. 28 centimeters squared times height is 28 H. We remove the centimeter. And so, what we have? We have 84 is equals to 28 H. So that, I think this, I need to, so right? So this is 28 over 28. For you to be able to get the height, you divide both sides by 28, by the coefficient of H. Coefficient means the number that comes before the unknown. So you divide both sides by 28. So you remain with 8 is equals to 84 over 28. So you start simplifying by 2, 14, by 2, 42. By 14, 1, by 14, 3. So our height is equals to 3 centimeters. Come and fill here, 3 centimeters. If you want to know whether you are correct, just pick using the other formula. Volume is equals to length times width times height. Say the length is 7 times 4. So 7 times 4 times height 3. And if you are not getting it a 4, then you are wrong. So 7 times 4 is 28. What is 28 times 3? 4 carry 2, 84. So 84 centimeters cubed. Meaning that your height 3 centimeters is correct. So that's how you'll do to be able to get questions on exercise 85. So these exercises are very, very important. Let's do them on page, that is pages 139, 139 through 141. 139 to 141. Let's do those questions and do them well. We will be able to get that those volumes that we are supposed to get there. Then in our next lesson, of course, we are going to look into cross-sectional areas of cylinders tomorrow in our next lesson. So thank you and may God bless you.